Imagine a golden eye, floating a million miles from Earth, far beyond the reach of any human hand or machine. Suspended in the silent void, it gazes out into the vastness, its mirrors gleaming with the promise of discovery. This eye peers into the universe's oldest corners, searching for secrets hidden in the darkness, where light from the earliest stars still travels across unimaginable distances. This is the James Webb Space Telescope, JWST, a marvel of engineering and imagination. It's more than just a telescope, it's a time machine, letting us glimpse the dawn of cosmic history when the first stars and galaxies were born. Its mission is ambitious: to uncover how the first stars and galaxies formed, to witness the birth of light in a universe once shrouded in darkness, and to trace the origins of everything we see today. Webb also searches for life's building blocks, scanning the atmospheres of distant exoplanets for signs of water, carbon, and other ingredients essential for life as we know it. In doing so, it helps us understand our place in the cosmos, connecting the story of distant galaxies to our own existence here on Earth. Unlike backyard telescopes or even the legendary Hubble, Webb sees in infrared, light invisible to our eyes, but crucial for unlocking ancient mysteries. This allows it to peer through cosmic dust and see objects that have been hidden from view for billions of years. When Webb looks at distant galaxies, it sees them not as they are now, but as they were billions of years ago, capturing the faint glow of their youth, frozen in time by the speed of light. Building and launching Webb was a feat of global collaboration. Thousands of scientists, engineers, and visionaries from around the world worked for decades to create its gold-coated, origami-folded mirror, overcoming countless technical challenges along the way. Once in space, Webb had to unfold perfectly, a nerve-wracking, flawless performance a million miles from home, with no chance for repair if anything went wrong. Every step was a leap of faith, and the world watched in awe as it blossomed open. With this new eye, astronomers expected to find the faint glimmers of the first galaxies and star nurseries, to witness the universe's earliest moments and answer questions that have lingered for generations. We were ready for wonders, prepared to be amazed by the beauty and complexity of the cosmos. But as the first images arrived, the universe had a surprise in store. One that no one had predicted, something so unexpected, so astonishing, it sent shockwaves through the scientific community. The data challenged our theories, forcing astronomers to rethink what they thought they knew about the early universe. The cosmos was about to challenge everything we thought we knew, opening a new chapter in our quest to understand the universe and our place within it. The discovery began quietly as the James Webb Space Telescope turned its gaze toward the Serpens Nebula, a region of space shrouded in mystery and dust, far from the familiar constellations we see from Earth. This nebula is a stellar nursery, a cosmic cradle where new stars ignite and take their first breaths, surrounded by swirling clouds of gas and dust. Using Webb's powerful infrared vision, astronomers were able to peer through the thick veils of dust that usually hide these regions from view, mapping the intricate structure of the cloud and analyzing its unique chemistry in unprecedented detail. At first, the data appeared routine, just another step in understanding how stars and planets form, but then, Webb's sensitive spectrographs picked up a chemical signature that was completely unexpected, something that didn't fit with any known patterns. Scientists double-checked their instruments, searching for errors or interference, but the strange signal remained, consistently coming from the coldest, most ancient parts of the nebula, places where time seems to stand still. What they uncovered was astonishing, a complex organic molecule, far more elaborate than anything previously detected in the vastness of space, with a structure that hinted at a level of organization rarely seen outside of living systems. These molecules formed spore-like casings, reminiscent of the protective shells made by fungi or bacteria on Earth to safeguard their genetic material from harsh environments. They weren't living organisms, but their highly organized, resilient shells seemed eerily similar to the products of biological processes, as if nature itself was experimenting with the building blocks of life. The idea of finding such intricate, organized structures floating in the empty vacuum of space was both baffling and thrilling, challenging everything scientists thought they knew about chemistry beyond Earth. Instead of the simple, random chemicals they expected, astronomers found what looked like a cosmic spore, a molecular container for life, existing in a place where life should be impossible. The implications of this discovery were staggering. Instantly, new questions arose. Could these structures be a natural precursor to life? Or do they hint at processes we have yet to imagine? The search for answers had only just begun. So, what are these cosmic spores? Normally, space clouds contain simple molecules: hydrogen, carbon, oxygen, basic Lego bricks. Webb found not just bricks, but a complex hollow sphere of interlocking carbon rings, seemingly designed for protection. On Earth, such containers shield life, plant seeds, bacterial spores, against harsh environments. These cosmic spores have multi-layered, durable shells resistant to deadly ultraviolet radiation. Our current chemistry can't explain their spontaneous formation in space. It's like finding a Swiss watch on a deserted beach. Are these the result of unknown chemistry, or fossilized remnants of ancient microscopic life? Either answer would revolutionize our understanding of the universe. This finding challenges the Great Filter, the idea that life's origin is a rare, improbable leap. If cosmic spores can form naturally in gas clouds, the universe may be far more capable of creating life's building blocks than we thought. The leap from non-living chemistry to life might not be so vast. This changes where we search for life, not just on Goldilocks planets, but in the chaos of stellar nurseries. These spores could seed new planets as they form, giving them a head start. Planets might be born with advanced organic molecules already mixed in. Life could start faster and be more common than we ever imagined. The universe may be primed for life from the very beginning. What if these aren't just complex molecules but evidence of a biological process? Imagine for a moment that what we're seeing through our most advanced telescopes is not just random chemistry but the fingerprints of life itself, etched across the vastness of space. This isn't proof of aliens, but perhaps fossilized machinery of microscopic life. Tiny remnants, preserved in ancient meteorites, could be the echoes of living systems that once thrived far from Earth, hinting at a cosmic story billions of years in the making. Maybe life once existed in interstellar clouds, building these protective shells, independent of planets. These clouds, rich in organic material, might have served as nurseries for primitive life, long before planets like Earth even formed. The idea, called panspermia, suggests life's seeds drift through the galaxy, waiting for fertile ground. These microscopic travelers could hitch rides on comets and asteroids, spreading the potential for life from star to star, across unimaginable distances. Webb's discovery gives this theory new weight. With its unprecedented sensitivity, the telescope is revealing chemical signatures and structures that challenge our understanding of what's possible in the cosmos. If true, Earth might be just one of many gardens where cosmic seeds took root. Life could be a universal phenomenon, blossoming wherever conditions are right, not a rare accident unique to our world. Even if these structures aren't biological but a new kind of chemistry, the implications are profound. It means the universe is capable of assembling the building blocks of life on its own, in the cold depths of space. The universe may naturally create the very structures life uses. Self-organizing molecules could be far more common than we ever imagined, forming spontaneously in the right cosmic environments. The path from non-life to life could be a broad highway, not a narrow road. If so, the leap from chemistry to biology might be a natural step, repeated countless times across the stars. The cosmos may be far more hospitable to life than we ever believed. Our search is just beginning, and every new discovery brings us closer to understanding our true place in a living universe. News of the discovery sparked deep skepticism. Extraordinary claims need extraordinary evidence. Scientists checked every possible error, but the signal was real. As evidence mounted, skepticism turned to excitement and a frenzy of collaboration. Physicists, chemists, biologists, and astronomers united to solve the mystery. The discovery broke down barriers between disciplines, making even veteran scientists feel like students again. Everything about interstellar chemistry was suddenly up for debate. The global scientific community mobilized, proposing follow-up observations and experiments. Everyone wanted to see if these spores existed elsewhere. Labs on Earth raced to replicate the nebula's conditions. The discovery ignited a new race, not between nations but between ideas. This discovery could rewrite our cosmic story. We thought the universe's complexity developed slowly, step by step. Now it seems complexity, or something like biology, might appear much earlier than we thought. The line between chemistry and biology may be far blurrier than we imagined. If these structures are common, they could shape planet formation and the origins of life. We're no longer just searching for water, but for advanced organic structures. The universe may be a dynamic system constantly generating complexity. Our story is part of a grand, interconnected cosmic saga. For centuries we've wondered, are we alone? The James Webb Space Telescope brings us closer to an answer, making the universe feel less lonely. The cosmos is more mysterious and surprising than we imagined. Each new answer leads to more questions. The journey has just begun. Scientists will spend years unraveling the meaning of these cosmic spores. We live at the dawn of a new age of exploration, privileged to witness it. Science is about the joyful pursuit of questions, not just answers. With tools like JWST, we're finally finding the most interesting pieces of the cosmic puzzle. So, if you could control Webb for one night, where would you point it? The universe is full of secrets. What question would you ask the stars?